Jason with Summit Machine Tool, and today we're showing you the SmartCut CNC lathe with the Fagor 8055 FL control. This is going to be the main screen right here. This is going to show all your coordinates of your axis coordinates, your spindle speed. Then you're going to have another window that shows all your tool data. This is going to be the tool that's actually up, your offset, your tool change position. Then we have our spindle screen right here that's going to show your programmed RPM, the percentage of your spindle override, the maximum set spindle speed, the gear range you're in, and then the indexing of the spindle. Then we have the last one, which is going to be your feed rate. This is going to show your feed rate programmed, the percentage, and then what selector we have set on, if it's hand wheel, incremental, or just a feed mode. Okay, this area right here is all your spindle controls. This is your constant surface speed, or RPM. This is going to be your cooling on, cooling off. This is going to be spindle clockwise, counterclockwise, spindle stop, spindle clockwise, counterclockwise. This is going to be your percentage all the way down to 50%, up to 150% of your spindle override. This next section actually shows your axis directions. This is going to be for your conveyor. This is going to be for turning tapers with your hand wheels, turning radiuses for hand wheels, and this is going to be a manual tool change for your turret. Okay, right below the screen you'll see your F keys. These are all your function keys. Each function key has a certain area that it talks about, or that it will get you into programming. F1 being your tool calibration. This is your calibration screen. This is where you want to actually insert the dimension of the part you're touching the tools off of. Let's say, for instance, 3" 1/1000. Okay, then this is going to be your tool number, your offset number. This is going to be the shape of your tools. This is going to be for turning or facing, or boring. This would be for threading, grooving, your radius tool. This would be a drill bit, reamer, tap. So let's go ahead and set this one up for a turning tool. This is going to be the shape of the tool, how it's pointing in the actual insert. So this would be for back turning or back facing, turning, facing or turning, facing, facing or boring, boring, back facing, boring, back facing. So our tool actually looks like this, which is F3. Hit enter. Okay, now this is where you actually go up there and you want to touch off your part. So you turn the spindle on, come up here and touch off the part and press your dimension here. So you want to press X enter. When I press X enter, it's going to save that data, change this, and put it over into your calibrated part dimension. Same thing with Z, is once you're done here, you can press your Z enter. Once you touch off on the face, press Z enter, and then it's going to recall that dimension of the part, insert it into here. Then you have your geometry. This is going to be the shape of your tool and how the maximum width or cutting dimension of your tool, the angle that it's sitting in the holder. So our instance, we have a profiling tool, so it's going to be 35 degrees. It's going to be a 1/2 inch maximum cut. This is going to be the angle that it's sitting in the insert, which is 93 degrees. And this is going to be the radius that's on the tip of the tool, which is 16 thousandths radius. Okay, the next cycle we're going to show you is our turning cycle. Just press the F2 key. It's going to come up and show you two different turning cycles. Cycle 1, which is just basic turning, internal, external, and cycle 2, which is a little bit more complicated, where you can actually put radiuses or chamfers on all three corners. Let's go through the turning cycle real quick. So we want to do an external profile, press enter. Say we want to start our dimension at 3 inches, Z0, 3 inches, and we want to cut back 1 inch, so -1 inch. We want to cut to a final diameter of 2.5 inches. We want to put a radius on this corner right here. So we want to toggle through, find our radius key, enter the amount of radius. So we want to put 50 thousandths radius. 3, we want to just use our tool radius, so it's going to be a square corner. And 4, we want to put a chamfer in here. So you select our chamfer, put the amount of chamfer, set up our safety distance, which is 100 thousandths, RPM, maximum RPM, direction of your spindle, cooling on, cooling off, your feed rate, which was 15 thousandths, our spindle speed on our roughing cycle, which is 800 RPM. Select our tool number, offset number, depth of cut, which is going to be a 1/8 inch depth of cut. Then we want to select our finishing feed rate, 7 thousandths per rev, 850 RPM. Tool number 3, which is our finishing tool. We want to cut 10 thousandths off on our finish cut and 2 thousandths off on our shoulders, which is Z. Once we get this set up, we can go to our graphics key. We can clear screen, set up our solid graphics, or we have toolpath graphics. Solid graphics, a little bit nicer to look at. Turn our feed rate down, press cycle start, and it's going to go through the operation. Let me slow it down a little bit. That's it. That's for graphics and our turning cycle 2. Next cycle is going to be our tapering cycle. F4 for tapering cycle. There's 3 different tapering cycles. The first one is if you know the given angle of taper. The next one is going to be if you don't know it and you know the start coordinates and end coordinates of the tapering. And then the third cycle is going to be a chamfering cycle, so you know the corner, the size of chamfer, and the angle of chamfer. Let's move on to the threading cycle. There's actually 3 different threading cycles on it. There's a straight basic thread, which is going to be threading cycle number 2. What's nice about threading cycle number 2 is it gives you a library of threads here, where you can use metric threads, coarse, fine, inch threads, coarse, fine, Whitworth threads, coarse, fine. Just by selecting the type of thread, then you select the diameter of thread, it'll automatically give you the pitch and the height of the thread. For instance, if the thread is not in here, in one of these libraries, you have to select free thread, then you can make up your own pitch and own depth. You can either select the pitch of the thread or the threads per inch. So let's go threads per inch. We want to do 12 threads per inch. We want to do our depth of our thread. Our thread exiting distance, what the exiting distance is the end of the thread, it's going to start pulling that thread out. So the thread's going to kind of disappear without having to have a required thread relief. So you program that in there, safety distance, RPM, the threading insert, the depth of the thread on the first cut is going to be 25 thousandths. Then we have some nice options down here for threading. This is going to be a decreased penetration. What this is going to do is each pass is going to be less and less and less. So the first pass is going to be 25 thousandths, then it may go 20 thousandths, 15 thousandths, 10 thousandths till it gets down to its final thread. Then we have another option here where this is going to be how it's going to cut the thread on the insert. This option is going to cut it on both sides. Each time it's going to cut both the left hand and the right hand side of the insert. This option is going to give us 3 different options to cut the thread on the level of the insert. This is going to cut the left hand and the right hand. This is going to cut just the left hand, so each pass it's going to progress a little bit to the left. So it's only cutting on one side. Then it has a zigzag option where it's going to cut off the left side, and then the next pass is going to fall behind and cut off the right side. So we enter that in there, enter our relief angle of 29.5 degrees. Then we have an option here to repeat last pass and do not repeat your last pass. Okay, now we're going to show you the grooving cycle. F7 for grooving cycle. You have 5 different grooving cycles. The first cycle is going to be a basic internal-external groove. The second cycle is going to be a face groove. Next cycle is going to be a profile groove. What's nice about this cycle is you can actually create chamfers or radiuses on all 4 corners of the groove. And you can actually change the angle of the groove wall with this A and this B here. It gets you some more options that are real nice down here. After you go through your roughing and finishing, you can actually machine from the center of the groove, and then it'll go to the left and go to the right of your grooving cycle, so you're cutting on both corners of your grooving insert instead of just cutting on one corner of the insert. Then we have an option here where you can actually come in there and groove down to the finished diameter, or you can peck with a chip removal. So it's going to come in, break the chip, come in, break the chip, or it has a zigzag where it's going to come in, break the chip, zigzag, come in, break the chip. So it's going back and forth and kind of roughing that groove out. We have another option down here. It's really nice for finishing, where it's going to come in one side of the groove, go past center line, come back out, and come the back side of the groove, past center line, come out. So you're actually cutting on both sides, and it's finishing the walls instead of dragging up one side of the wall with the grooving tool. Moving on to the third cycle, or the fourth cycle, which is going to be our profiling groove on the face of our part. And then our final cycle, which is our cutoff cycle. What's nice about this cutoff cycle is you can program a chamfer or a radius on the very end of the corner. So you can use your grooving tool to actually put a radius before it parts off the cycle. So it eliminates any second operation of chucking the part back up to create a radius on that sharp corner. Another thing it does, it has a option, and say you're cutting a thin wall tubing and ring and you do not want to crush or egg shape the ring, Fegor gives you this option to tell you the amount before it actually breaks through. You can give it that amount, and then you can give it a feed rate, so it's going to slow the feed rate down tremendously so it does not crush the part. And that's it for grooving cycle. Okay, we're going to go to the profiling cycle now. There's actually two profiling cycles. There's profiling cycle number 1. This cycle is used if you have up to 12 predefined points. Just putting the coordinates of each corner will develop a profiling cycle. First thing it's going to be is internal, external. Just by pressing this toggle key, it changes from internal to external. Next one's going to be programming to the headstock or programming to the tailstock. The next option is going to be if you want to do profiling passes, the full contour of the profile, or if you want to take straight roughing cuts and then finish with a profile cut. So this is predefined points. Just by putting X0, Z0, it's going to start off in center. After the first point and in between the 12th point, you can put radiuses or chamfers on each one of the corners. And then just set up your part coordinates. This is going to be part size. Set up your spindle speeds, your roughing feed rate, roughing RPM, tool number, depth of cut, finished feed rate, finished RPM, and then the depth of cut on your finished feed rate. And that's it for programming. Okay, let's go to profiling cycle number 2. Hit level cycle. We're going to do outside profiling. We're going to profile towards the headstock. Straight cuts with a profile finish cut. Now we want to give it a number, and we want to hit recall. This takes us to the profile editor. This is the mini CAD/CAM system. This is where we actually draw on the machine to create the profile of the part. So let's go edit, profile. It's going to ask you for our initial coordinate, which is going to be 0, 0, hit validate. It gives us our G-code coordinate for that start point. Then we want to do a straight line. Let's do straight line, Z0, X 0.875, enter, validate. It shows the line, wrote another code of G-code. Now let's do counterclockwise arc. My Z ending is going to be negative 1.75. My X ending is going to be 1.125, enter. I don't know what my centers of my radius are, so I'm going to go down to radius and put 1 inch, enter. It displays it here, hit validate, that looks okay. Now we want to do another straight line coming off this. So hit straight line. My Z ending is going to be negative 2.75. X is going to be 1.25, enter, validate. Create another G-code, create our straight line here. So let's go and do one more straight line to break that edge. It's going to be the same Z value of negative 2.75, enter. Our X is going to come to 1.875, enter. Just brought it straight down. It's good, validate. Now let's go over. So we go straight line to negative 3 inches. X is going to be the same, 1.875, enter, validate, straight line to Z negative 3.25, enter. X is going to drop down to 1.25, enter, validate, and then do one more last straight line to finish the part out. Negative 4 inches. What's nice about this, it has a calculator. Say you don't know the exact length of it, you just know the difference from one point to the next point, like an incremental move. Let me demonstrate that. We know that right now we're at negative 3.25. We know we got to move an extra 750 thousandths. So if you put another negative 0.75 and hit enter, it adds those in. Four inches. Okay, it's going to be the same X, 1.25, enter. Okay, our part is complete. Okay, now we want to go and put radiuses on each one of those corners. So you come in here and you go to where it says corners, rounding. This is our first intersection where we can put a radius, so let's go 100 thousandths right here. Next one, let's go 200 thousandths. We can do another 200 thousandths here if we want. Let's just use the tool radius for that one. So we'll skip that one, hit next element. We'll move on to this one. Let's go do a 30 thousandths right there. That's it. Now we're finished here, so you want to press escape to where you see where it says continue, and then press escape to where you see where it says finish, and then we can give it a name. Enter. Okay, this brings us back to the program itself. We have our profiling cycle right here, so press enter. This is where we're going to put the stock size. Our stock size measures, let's say it measures 2.5 inches. I'm going to start out at 1/8 inch from the Z0. Safety distance at 100 thousandths in X, 100 thousandths in Z. Set up an RPM. Going to counterclockwise, coolant on. Our feed rate is 13 thousandths per rev. RPM is going to be 800. Tool number is going to be tool number 8 because that's our profiling tool. Okay, this is going to be our depth of cut, which is, let's go 125 thousandths depth of cut on our roughing pass. This is going to be our exit withdrawal from each pass, so it's going to come out at an angle instead of drag on the shoulder of everything. So our M codes, if we need them, we're going to slow down to 5 thousandths per rev on our finishing pass, speed it up to 1,000 RPM, use the same tool, and this is going to be 10 thousandths off our roughing, or excuse me, our finished cut. If you go back to here, you have an options where you can actually change the amount you want to take off on your finished pass. Like say I want to take off my 10 thousandths in X and 2 thousandths in Z. You can select the different amounts. And this is going to be machining with the X or the Z axis. This will be machining with the X axis. See how it changes right here. So you can change and flip-flop. Now let's go to graphics. Go typographics, XC solid. Make sure our display area is good. Clear screen, hit cycle start. And it's showing a simulation of the roughing cycle right now. And then it's going to show the finish cycle. And that's it. That's profiling cycle number 2.